Hi,
Oh,
sir. How are you?
yeah, hi. Yeah, I'm doing good. I'm doing good. Okay. So in the last class, we were doing combustion and flame, and we have learned about combustion. We have learned different things. We were learning about the fire actually, right now, the different agents of fire, how we can extinguish the fire. We were learning about this. So by removing these things, yeah, Priyanka,
Sir, like my name,
repeat again.
my name on
Yeah.
these.
Oh, okay, okay. No worries. Let me rename you.
I couldn't do it, sir.
No worries, Priyanka. Oh, that's better now. Yeah, so we were learning like how we can control fire right now. So any fire needs three things to be present right now, like fuel, air, and heat. If you remove any of these things, then the fire can be extinguished. So we learned about these things. Okay. Also, there are some particular cases like if the cause of the fire is uh, water right now, so then what measures we have to take? It's not water, I mean, just if the cause of fire is electricity, or if the cause of fire, let's say, is due to oil, right now some amount of liquid fuel is burning, then how we can extinguish it? We have learned that, right? So where we have learned that if the cause of fire has been an electric short circuit, so thereby water is not the preferable option to extinguish it, right? Rather we can use sand, or we can use the fire extinguishers that are available, like we can use the carbon dioxide fire extinguisher, right now foam extinguishers. There are different type of extinguishers available in the market. Nowadays we have many options. Like now you have this CO2 carbon dioxide fill extinguisher. You also have got another form of extinguisher in which powder is filled right now. In some type of extinguisher, foam is filled. So different options are there which we can use. Okay, that's the thing. Again, if the cause of fire is oil, like petrol is burning, because of which the building has catch fire. There are some tanks of petrol which is on fire. So then again, you cannot use water. What was the reason behind it? Remember, we have discussed about it.
Sir,
If you
oil and water do not mix.
exactly, it does not melt. And what will happen? The water will go down. Water is heavier than oil now. Oil will float above the water. So oil will still be on fire, right now. Oil will come to the top of water and will still be on fire. So that's the thing. Now, why during an incident of fire, one is advised to wrap a woolen blanket over a burning object? Particular object, or suppose if a person, unfortunately, if a person has caught fire, so it is advised to wrap that person with a blanket. What you can do, you can moisten the blanket, dip it in water, and then wrap the person with blanket. What could be the reasoning behind it? The reasoning behind it is that we are trying to cut off the air supply from the body. We are trying to cut off the air supply, no? Because fire needs
Yes.
air. So if you cut off the supply, so by wrapping the person with the blanket, we are cutting the air supply. So thereby, in this manner, we will be quickly able to extinguish the fire. Right? So blanket cuts the supply of oxygen, or particularly cuts the supply of oxygen to the object that is burning. Thereby, it prevents it from burning further. Hope that much should be clear to everyone so far. Right? Then, then what are the first aid treatment a person needs to take if unfortunately they have caught fire? Right? There are different types of damage done to the skin. No? First degree burn, second degree burn, third degree burn. You might have heard about these terms. Getting it? No? Okay. So thereby, obviously, one should not be using like what do we say, like home-based remedies should not rather be preferred, but one should immediately rush to nearby hospital, right? So that's the first thing that the person needs to do. Okay. We also learned about the fire extinguisher. Right now, fire extinguisher, it's a device used by the fire brigade to control fire. The role of the fire extinguishers is to cut off the supply of oxygen or bring down the temperature of the fuel, or both of them. That is how a fire extinguisher basically works, right? You can see these firemen. Okay. Now, the most common fire extinguisher is obviously water. If something is on fire, obviously we will basically throw water over it. That's the most common fire extinguisher we use. But water works only when things like wood and paper are on fire. Right now, this thing we already have discussed previously. Like if electrical equipment is on fire, water may conduct electricity and it may harm those that are trying to dose the fire, that are trying to extinguish the fire. So water is not suitable for fires that involves oil and petrol and where the cause of fire is electricity. Right now, also you know that water is heavier than oil, so it will sink below the oil and oil will keep burning on the top of it. So fire involving electrical equipments and inflammable materials like petrol. So there, carbon dioxide is the best extinguisher. Like this one over here, it's the best extinguisher. And how does it work? So carbon dioxide extinguisher works in the following manner. Suppose there's some wood over here. Do we have empty space? No. So suppose there are some wood that is on fire, that is burning. And let us say we are trying to understand the working of this carbon dioxide fire extinguisher. So we will be basically using it over it. Okay. So what happens earlier, as this wood is burning, so it has enough supply of air. It is surrounded by air, right, Priyanka and Bhupakar? It has air or particulate. It has oxygen air around it, right or no?
Yes, sir.
Say that these are the molecules of oxygen surrounding the fire, with the help of which fire is burning. Because oxygen is a supporter of combustion. It's a supporter of fire, as you know. Now, when I will be using this carbon dioxide gas to extinguish it, so basically I'm releasing the carbon dioxide gas around it. It's kind of like this. So these are the carbon dioxide molecules that are going to surround it now. Also, you should know that carbon dioxide gas, now, it's heavier than oxygen. What I'm saying, carbon dioxide gas is heavier than oxygen. So what it will be trying to do now, it will try to push away the oxygen gas. What it is trying to do, it will push away the oxygen from here. Getting it, guys? So the oxygen will be actually moving out of from here. Getting it? The oxygen will move out from here. So carbon dioxide gas being heavier, it will expand, it will push the oxygen away from the fire. So here we are cutting off the supply of oxygen to the fire. Getting it? So as soon as this container is opened, the carbon dioxide comes out of the nozzle. That carbon dioxide will surround the fire. It will push away the oxygen, right? And in this manner, fire is extinguished. You guys getting it how it works?
Yes, sir.
Yes, sir.
Good. Okay. Further in the paragraph, it reads that also the basic same thing. Carbon dioxide gas being heavier than oxygen covers the fire like a blanket. As you guys can see here, it has covered the fire like a blanket. Okay. And will push away the oxygen, right? Also, the added advantage of carbon dioxide is that it, in most cases, it does not harm the electrical equipment, right? Like if some computer cables, like computer has catch fire, some cable wires, some wires have catch fire support. So thereby, even if I were to use the fire extinguisher, this carbon dioxide fire extinguisher, is it going to harm the equipment? It's simply gas, no? It's not going to harm. But if other things were to be used, like you throw sand over it, you threw some blanket, some water or some other thing, then it is going to harm. In fact, the person may also get harmed if they were to use water. Okay, that's the thing. Now the question is that how do we store the carbon dioxide gas into this cylinder? It's a gas now, so how do we store it in this, right? So question is, how do we get the supply of carbon dioxide? So it can be stored at high pressure as a liquid in cylinders. You guys know that gas can be converted into liquid, isn't it? Right? The LPG cylinders that we use. You guys also use LPG in your house also. LPG would be used there, liquefied petroleum gas. Right?
Yes.
So in that cylinder, what is it? Is there a gas or is there a liquid inside that cylinder? Tell me. In the LPG cylinder, it's liquid.
Liquid.
As the name is liquefied petroleum gas. So petroleum gas has been converted under high pressure into liquid in those cylinders right now, right? So thereby, when that gas is released from the LPG cylinder, when that gas is released, when it is released, I mean to say, when the LPG is released from the cylinder, it comes out in the form of gas and then burns, right? A liquid does not comes, but rather a gas comes out of it. In the same manner, these carbon dioxide gases can be stored under this small cylinder in the form of liquid under high pressure. Okay, under high pressure. Okay, so that's the thing. Okay, so what is done in this small area, a small volume, so much of carbon dioxide gas is stored in the form of liquids. So as soon as the nozzle is opened, this carbon dioxide gas would be expanding. It expands, as it is written over here, that when it is released from the cylinder, when carbon dioxide gas is released from the cylinder, so it expands enormously in volume and cools down. So it not only forms a blanket around the fire, it also brings down the temperature of the fuel. Right? So this carbon dioxide gas will be coming out of the cylinder and it enormously expands. It expands over a large area and it also is very cool. So it will be cooling down the fuel also. It will be bringing down the temperature as well. So thereby, it is one of the excellent fire extinguisher that we have. In fact, one should have it at home. Okay, no? One of you was telling that you guys have this at home. I think it was you, Abubakar, I suppose. Right. So that is one of the way. You can store this carbon dioxide gas in the form of liquid in these containers. Okay. That is how we can use it. And that is the way how it is stored in the modern fire extinguishers nowadays. But there's another method also. Where you can have certain chemical substances stored under the cylinder and a reaction will take place inside it and thereby the carbon dioxide gas will be released from that. What I mean to say that another way to get carbon dioxide gas is to release a lot of dry powder of chemicals like sodium bicarbonate or potassium bicarbonate near the fire. These chemicals will also be giving off carbon dioxide gas, meaning that what is being mentioned over here, one of the way you have understood now from where you can get carbon dioxide gas, how you can get it, by storing it in under high pressure in these small cylinders in the form of liquid. As soon as you open it, the carbon dioxide gas will be coming out of it. It will be expanding and will cool down the fuel. Understood, both of you, right? Okay.
Yes, sir.
Now another way is like, how else can we get carbon dioxide gas? The carbon dioxide gas is already present in there, but we have to get it in so much of quantity. So another way is that, suppose again there's a fire over here, some wood is burning. Okay, so we all have baking soda at our home in the kitchen right now. We use it for various purposes. So one of the ways that you can simply throw some baking powder over it. That is baking powder, or also called as baking soda, the same thing. So baking soda, it's basically a chemical known as sodium bicarbonate. In the sixth grade, in the seventh grade, you guys have learned about it, right? Now, where we learned about acids and bases and all that, right?
Yes, sir.
Good. Another thing is that when sodium bicarbonate is heated, now when it comes in contact with fire, it releases carbon dioxide. Getting what I'm trying to say? So it will be releasing carbon dioxide gas. So carbon dioxide gas will be released, and that carbon dioxide gas is again going to form a blanket around it. It will form a blanket, it will push the oxygen away, and it will cool down the fuel. So that is the way. Other than carbon dioxide, other than baking sodium bicarbonate or baking soda, you can also use some other chemical substances. Like what are they? So you can use potassium bicarbonate, can also be used. Potassium bicarbonate powder can also be used. Remember, these chemicals are available in the form of powder. Okay, no? You can get it in the form of powder, just sprinkle it over the fire, it will release carbon dioxide gas. So these powdered chemicals can be used. Okay, so that is how you can get carbon dioxide gas. Either like it is available in the market in this form, you can purchase it, or either you can just have some baking soda or potassium bicarbonate at your home. If accidentally something is on fire, you can sprinkle over it, the fire will be getting extinguished. Hope that much is clear to both of you. All right.
Yes, sir.
Also, you guys can see how that dry powder basically works. The sodium bicarbonate, which I was telling you, this is sodium bicarbonate. Like that's the chemical formula. Sodium bicarbonate is the chemical name of baking soda. Okay, now baking soda is the common name, household name. Since it is used for baking, in the baking industry it is used, so it is called as baking soda. So when it is being thrown over the fire, you can see how carbon dioxide gas is being released. Forget about these other things. Basically, look at how carbon dioxide gas is being released. Okay. So fire extinguishers, we were learning about the fire extinguishers so far. They are the devices that is used to put out the fires. They either cut off the air supply to fire or cool off the fuel below their ignition temperature, or both of them will be done at the same time. Right? So there are different types of fire extinguishers. One we have learned. So dry powder, one was sodium bicarbonate, another is potassium bicarbonate. You throw it over the fire, carbon dioxide gas is going to be released. Now, previously, soda acid fire extinguishers were also available, right now? Like many years ago, a very different type of fire extinguishers were available. And that also basically was working on the same concept of releasing carbon dioxide gas. Look at the structure of this first of all, okay now? Look at this. That is the metal cylinder. Okay, Priyanka and Abubakar. That is the metallic cylinder. Okay. Now inside the metallic cylinder, we have this glass tube. Look at this glass tube. Okay, now this is a glass tube which contains concentrated sulfuric acid. You guys know about sulfuric acid, right? Now it's a strong acid. So you have a very
Yes, sir.
strong acid known as sulfuric acid stored in this glass tube. Now this glass tube, you understood, then it is being held in its position with the help of wire gauge. Wire gauge, you understand, it's kind of like this. Okay, a structure like this is basically holding it in its place. On the other hand, you have this plunger that is basically made up of iron. Okay, now that will be made up of iron. And as you'll be pushing the plunger, this glass tube is going to break. Please tell me if that much is clear to all of you so far.
Yes, sir.
And that's good to know. Now,
Yes, sir.
this much area which you are seeing over here, this much area, that is filled with sodium bicarbonate solution. What is the sodium bicarbonate? Remember baking soda? So you have taken a solution of basically baking soda. Okay, now? So you took the baking soda, you have made a solution of baking soda and you have filled it with this. Now, when you have to use this to extinguish fire, what you're going to do, you're going to push the plunger. So the plunger will be breaking the glass tube, and as the glass tube will be breaking, so the sulfuric acid present over here is going to mix with the sodium bicarbonate or the baking soda solution. Isn't it? Yes or no?
Yes, sir.
There's going to be reaction, no? And as a result of this reaction, lots of carbon dioxide gas is going to be released here. So thereby, right after you have pushed the plunger, you're going to remove this wax seal. Like this opening of the metal cylinder is sealed with some wax. So you will be basically taking it off from here, and lots of carbon dioxide gas is going to be now released from here. Understood how it works? So as a reaction between sulfuric acid plus baking soda solution, that will be giving off lots of carbon dioxide gas will be released. So in this manner also we can get carbon dioxide gas. So how many different ways we have learned? In the very beginning, what we learned? We did learn about this type of carbon dioxide gas cylinders in which carbon dioxide gas is stored in the form of liquid. Now, in a carbon dioxide extinguisher, the carbon dioxide is kept in pressurized liquid form in the cylinder. When this container is opened, the carbon dioxide gas expands to form a gas in the air, right? Basically, it expands in the air and cools down the fuel and pushes away the oxygen. Second, we learned about the powder, dry powder fire extinguishers where we have chemical substances like sodium bicarbonate and potassium carbonate. Remember? Sodium bicarbonate and potassium bicarbonate. So these chemical substances can be just thrown over the fire. It will release so much of carbon dioxide gas. Then another way in which we can obtain the carbon dioxide gas is from the soda acid fire extinguisher. Like soda is basically baking soda, and you have this sulfuric acid. So that is the setup. This is the structure of this type of cylinder. When you push the plunger, sulfuric acid from the glass, right, it will be mixing with the baking soda and lots of carbon dioxide gas is released. So these are the different ways of obtaining carbon dioxide. Other than these, now there are some other type of fire extinguishers that are also available nowadays in the market. Like you have got foam type of foam type of fire extinguisher. As you will be opening the nozzle, so much of foam will be released, right? You have this water type of fire extinguishers also, okay, no? And the powdered one also, like this powder one will be basically containing powders of sodium bicarbonate, powders of potassium bicarbonate stored under high pressure. Hope you guys have understood about these different types of fire extinguishers. Any questions? Please tell me.
Yes, sir.
Okay. Answer this question.
Sir, all of the above.
That is all of the above. Very good. So water, foam, chemical, all of them are used. List conditions under which combustion can take place. Basically, we have learned about the factors of combustion.
Sir, antimony trisulfide.
Antimony trisulfide? Where did that came from? Priyanka, we're not learning of this. There isn't any question related to the matchsticks. Antimony trisulfide is one of the chemical substance that is present in the head of the matchstick.
Yes, sir.
And you have potassium chlorate also. Antimony trisulfide, potassium chlorate, it is present in the head of the matchstick.
Yeah.
So why you're answering that antimony trisulfide right now?
Sir, I thought it was the question. I don't understand the question, so I thought it was about the head, the matchstick affair.
No. It is saying list conditions under. Conditions basically means that like under what circumstances combustion will take place. Like something will catch fire. There will be fire. A combustion will be taking place when?
Water. I mean, sorry, air,
Air,
fuel.
fuel, and ignition temperature, or basically heat.
Yes, sir.
Under these three conditions, combustion can take place. No, availability of a combustible substance, that is fuel. Then supporter of combustion, that is air, particularly oxygen, and then heat, particularly ignition temperature. Okay, next, burning of wood and coal causes dash of air. What does it causes? Yes, you can have like, it's a simple logical question. You can think and answer. Yes. When coal is burned, when wood is burned, it gives off so many toxic gases, harmful gases are released: carbon dioxide, methane, sulfur dioxide, nitrogen oxides are given out, and these causes pollution of air. No? Right, Abubakar and Priyanka?
Yes, sir.
So some
Yes.
questions like you can basically answer like They're not that difficult. So they cause pollution of air. Next.
Sir, LPG.
Obviously LPG. Next.
Sir, combustion temperature.
There isn't anything like combustion temperature. Priyanka, what about you? Yeah. The last class we had, it was on 5th of June, right? There we have learned about few things, and if you remember, every terms which we use in the class, like we revise it almost
Sir,
in every class, no? Yeah.
is it ignition temperature?
Ignition temperature, you mean to say, right?
Yes, sir.
So that is ignition temperature. Good. So ignition temperature is the minimum temperature to which a fuel must be heated before it catches fire, before it burns. No? Okay. So fire produced by oil cannot be controlled by.
Sir, what?
That's obviously water. Very good. Okay. There are a few more questions. Let's do them quickly. Okay, try to answer them as fast as possible. Okay, now. So which of the following substances has the lowest ignition temperature? Spirit here basically would be referring to alcohol. Okay, now spirit, diesel, mustard oil, or kerosene. Which one of them will quickly catch fire on just low temperature?
Sir, alcohol.
Alcohol. Well done. Next. This one I would be helping you with this one, but still you guys try to answer it. By the way, Hajj holidays are over or is it still going on?
Sir, hydrogen.
No.
So what is the option D?
Option number D. That is chaff. Chaff is basically the seed coat. Seed coat. Okay, when you
Sir,
have so
then
much
it
of
is
seed coat.
C.
C. That is asbestos. Good. Okay, now see. Asbestos, it is used in construction and manufacturing for heat-resistant substances. Getting it now? But is now known as a health hazard. Like it has so many problems also. Okay, it is responsible for causing several kind of diseases also. But getting back to the main thing here, asbestos, it has high resistance to heat. Again, it has high resistance to heat. So it will not be burning up easily. So one of the following is not a combustible substance, that is asbestos. Well, hydrogen and alcohol, those are combustible. They would be catching fire, but asbestos does not. If you guys know, liquid hydrogen is used as a fuel. Right? And liquid hydrogen is used as a fuel, and particularly in the rocket engines. In rocket engines, liquid hydrogen is used as a fuel. Getting it, guys? So it is used as a fuel, and like it has almost zero emission. It does not releases harmful gases. So it's a very good fuel, and it has one of the highest calorific value. Okay. Which of the following is not used in making matchsticks these days?
White phosphorus.
Very good. White phosphorus. Next. Which of the following undergoes spontaneous combustion? Would be catching fire on its own without the application of heat.
White phosphorus.
Again, white phosphorus. That's correct, Pink. Very good. Next. Which of the following statement is not correct about carbon dioxide acting as a fire extinguisher for electrical fires? Which of them is not correct about carbon dioxide? So first statement, it is heavier than air. Second, it is lighter than air. It is not combustible. It does not support combustion. It is saying that it is not correct.
Sir, it is lighter than air.
It
Uh,
is lighter than air.
Exactly. That is not correct now because it is heavier than air. Good. Fires in underground coal mines usually occur due to coal dust many times would be catching fire on its own. So what kind of combustion is it?
Spontaneous.
Spontaneous.
Spontaneous. Good. Next, the calorific value of a fuel is 40,000 kilojoule per kilogram. The fuel is most likely to be. For such type of question, we would be
Sir,
required to refer to the
liquefied
table.
petroleum gas.
Liquefied petroleum gas. Okay, Priyanka, what about you? What do you think? What is the calorific value of LPG? As far as I can recall, it's obviously not 40,000, but above 50,000. Like it's a 55,000 kilojoule. 55,000 kilojoule per kilogram, I mean to say. Yeah. So in the list, you have different examples, different options are given. Like methane, you have biogas, hydrogen gas. Out of biogas, methane and hydrogen gas. One of them is correct.
Hydrogen gas.
Hydrogen gas. No, hydrogen gas has so much.
Sir, biogas.
That is biogas. Yeah, that is indeed biogas because like biogas has a calorific value somewhere between 35,000 to 40,000. So that is actually it's biogas option A. Which of the following fuel has the highest calorific value from the given options?
Sir, LPG.
LPG. Okay. What about others? What about you, Priyanka? If you guys remember that list, in the
No,
last
sir,
of that
natural
list,
gas.
that is which one? Hydrogen gas,
Natural
na?
gas.
No, not natural gas. It is asking you about the highest now. So look here, it's hydrogen gas now. 1.5 lakh. 1.5 lakh kilojoule per kilogram. Okay. So that one is the appropriate one. While natural gas, that is compressed natural gas, has around 50,000 kilojoule only. So hydrogen gas has 3 times more calorific value in comparison to natural gas. All right, guys. Moving on to the next question. On a cold winter night, the person sleeping in a room with closed doors and windows with a coal fire, the coal fire burning inside may die due to the excessive accumulation of this one, let me tell you. See, if in a closed room in the winter season, if we close the room, we close the windows and ventilators, everything is closed, and if something is being lit, right, something is burning, so due to insufficient air, in access to sufficient air, rather than giving carbon dioxide gas, it will be giving carbon monoxide. And if there's excessive accumulation of that carbon dioxide gas in the room, like suppose if coal is being burnt, right now some coal is being burned in the room, and that is a closed room, there is no inlet and outlet of air, there is no ventilation or room, no ventilation, no windows, nothing, if everything is supposed closed. So due to limited air, due to limited supply of air, coal upon burning will give you a gas called as carbon monoxide. Carbon monoxide, that is CO. And this gas is very, very poisonous. This is a poisonous gas. So if this gas is inhaled by us, now if it is inhaled, then what will happen? It will actually combine with the hemoglobin. So it will combine with the hemoglobin, and thereby it will form carboxyhemoglobin. Carboxyhemoglobin. So now instead of oxyhemoglobin, like oxygen should be flowing in our blood now, right, Priyanka? Abu Bakr, right? Oxygen
Yes,
should
sir.
combine with hemoglobin and should flow in
Yes,
our
sir.
blood. But now what is happening? This carbon monoxide gas is combined with the hemoglobin, and now it is flowing in the blood. So thereby it will disrupt the system of the body, and thereby will lead to death, will lead to slow death. The person will die in sleep. So that is carbon monoxide. Many times we get to hear a news that the people sleeping in the room, next day when when the room was open, they were all dead. Why? Because they were burning something in the room. Sorry, and there was no ventilation in that room. Which of the following burns without producing a flame? These questions will be able to do later on, but although you may be able to answer. Okay, we'll be doing these questions later on, okay, no? When we'll be learning about flame. So which of the following fuel has the lowest calorific value? LPG, biogas, CNG, or kerosene?
Sir, Keros.
Kerosene. Okay,
Sir.
what about yes?
Yes, sir. It's kerosene.
It's kerosene. I think it's biogas actually. If you look at the amount of heat given out by kerosene, like it's around 45,000 kilojoule per kilogram. But when you look at biogas, that is between 35,000 to 40,000 kilojoule per kilogram. Again, as for other gases like CNG, for CNG it's 50,000. LPG, obviously, it's 55,000. So that is actually biogas. Which of the following is the main cause of global warming? Yeah. You guys turn your cameras on. Yeah, is it nitrogen dioxide, sulfur dioxide, carbon dioxide, or is
Sir,
it
carbon.
ozone? Carbon dioxide, correct. Next, if the falling gas does not contribute to the formation of acid rain, is it carbon monoxide, sulfur dioxide, nitrogen dioxide, or is it nitrogen monoxide? It's actually, see, carbon monoxide, it contributes to, hold on. Nitrogen monoxide, you have nitrogen dioxide, sulfur dioxide, yeah. Nitrogen dioxide contributes, nitrogen monoxide also contributes, sulfur dioxide also contributes, but carbon monoxide does not contribute. So it's saying which one of the following does not contribute? So it's carbon monoxide. Option number B. Then which of the following is the most environmental friendly fuel to be used in automobiles? That is
Natural.
obviously. Which of the following does not involve a combustion reaction? The production of heat and light from kerosene in a lantern, production of heat and light from hydrogen in a rocket. Liquid hydrogen is used as a fuel in rocket, remember? Production of heat and light from hydrogen in the sun, or production of heat and light from wood in a bonfire. So which of the following does not involve a combustion reaction?
Sir, D.
No.
Sir, A.
No.
C.
Option C is the right one. Because in the sun, combustion is not taking place. Remember, in the sun, nuclear reactions are taking place. Getting it, guys? In the sun, what is happening? Nuclear reaction is taking place. So because of the nuclear reactions in the sun, so much of heat and light is given out. Okay, na? So nuclear fission reaction is taking place in the sun. Nuclear fission is taking place in the sun, because of which so much of heat and light is given out. And now we are going to start with the new topic, that is flame. Okay. See, we know that when a fuel is burnt, right? So when a fuel is burnt, heat is given out. Along with heat, in many of the cases, light is also given out, isn't it? Light is also given out. So what is flame? So flame is the visible and gaseous part of the fire. It's the visible and gaseous part of the fire. Okay, so if something is on fire, so obviously in most of the cases, a flame will be given, right? So it's the visible and the gaseous part of the fire. So what we see as the flame is the light energy released due to the combustion of fuel. When combustion takes place, heat is given out and light is also given out. So that light you see in the form of flame. But not all of the fuel gives flame. Like when you burn coal, does coal give a flame like this? Does coal give a flame like this?
No, sir.
No. Even when you burn charcoal, that also does not give a flame like this. Right? No? So that is the thing. So there are certain materials which upon being burnt would be giving a flame, while some of them will not be giving a flame. Okay, so materials that forms flame, right? Like candle would be forming flame, right? Candle upon burning gives a flame now. When you have magnesium ribbon, when that is burnt, it does not give a flame. I think you guys have seen that magnesium ribbon burning with that, which gives it white dazzling light, right now. Look at this one here.
Yes, sir.
So it is just giving a white dazzling light, but does not give off any flame. So burning of a candle will be giving a flame. Okay, a magnesium rod, when it burns, it does not form a flame. Camphor, it also forms flame. Camphor, you guys understand? Camphor, you guys haven't heard about it?
No, sir.
Okay. Charcoal, okay, charcoal actually gives flame. Okay, no, but coal does not give flame. So camphor, like a small, in the form of a small spherical, not this one, not this one. I really could not get the images. You guys give me 1 minute. Okay, now let me show you the images. Okay, 1 minute. Sure. Look over here. This is what I was talking about, this camphor. Okay, no? Priyanka, I think you might be aware of it, like particularly when, if you do puja, okay, if you do prayer, there, like
Yes, sir.
many times this thing would be burned. So that is basically camphor. These small white balls that you see over here now, Abu Bakr, that is camphor. So when it is burning, obviously it is giving off flame, right? So that
Yes, sir.
is camphor. Okay. So camphor forms a flame. Kerosene stove gives a flame, right? Charcoal also forms a flame. Then LPG gas, that also forms flame. So like this, we have so many different examples. Okay, answer the following question. Coal burns with flame, gives only a glow, both flame and glow, none of these.
Sir, only glow.
Only glow, that's correct. Next, burning of charcoal in a closed room will produce. Yeah. This you can relate with
I,
the question we did
all of
moments
these.
ago. No, it's saying particularly in a closed room. There's a closed room in which charcoal is essentially obtained from coal, na, basically.
Sir, carbon dioxide.
Sir, carbon dioxide.
No. So it is being burned in a closed room. Always remember, if you have coal and if you have coal and charcoal, right? Coal and charcoal are essentially made up of carbon now. The main component of coal and charcoal is carbon, right? Now, if normally it burns in an open air, if it is burning in an open place, so it will be giving carbon dioxide, it will be giving nitrogen dioxide, sulfur dioxide, different kind of gases will be given. But if it is being burned in a closed room where the doors are shut, where the windows are shut, okay, now where the doors and the windows, everything is shut down, there is no ventilation in that. So upon being burned, that charcoal is going to give a poisonous gas, which you guys have moments ago learned about, right? And that gas is nothing but carbon monoxide, that is CO. So the room will be filled with carbon monoxide gas, and if the person were to be sleeping in that room, they may actually die in their sleep. So that is carbon monoxide. Is that clear?
Yes.
Now we are going to learn about the structure of a flame. Right now, if you have noticed the burning of a candle, so you would have noticed this thing that it has got different zones. The yellow zone, the blue zone, the black zone, the dark black or the dark zone, right? So we're going to learn about it, like why they have different colors, which is the hottest zone. huh? So we'll be learning about that. So flame consists of three zones or three parts basically. They are the innermost zone, middle zone, and the outer zone. Right? And all of these zones have different colors and different temperatures. We'll be learning which is the coldest zone, which is the hottest zone. Such things we are going to learn about. Take a look at this structure of a candle flame. Okay. By the way, a basic thing you guys should know that when a candle is being burned, both physical and chemical changes takes place. Right now, we have learned about this in the previous grade. Okay. The melting of the wax is a physical change, while the burning of the wax vapor is a chemical change. So how is it flame? How the flame is being produced? It is being produced due to the burning of the wax vapors. The wax vapors are burning and hence flame is being produced. Clear or not?
Yes.
It's the wax vapor that is burning to give off the flame. Okay. First of all, take a look at the innermost zone, right? And this dark zone that you see here. It's the least hot zone. It is black in color and it is containing unburned wax vapors. Right? In this zone, those wax vapors are found which have not burned properly, like they are unburned. So you know that if it is not burning properly, that's why it is having a dark color. Also, it is in the innermost part of the flame. So it is not having enough access to air right now. It is in the innermost zone now. Let me zoom it out again. Look at this zone here. Is this zone in direct contact with the air or the outermost zone, that is the blue zone, in direct contact with air? Tell me this thing. It's the outermost zone, no? That is getting more air. So the innermost zone, right, it is not getting sufficient amount of air. So combustion is not happening properly here. Right now, the wax vapors are unburnt. It is not burning properly. Right? So thereby, will the temperature be more or will it be least? Since it is not burning at all. It will be least, no? The temperature is going to be least. Okay. Now we are going to the second zone or the second part of the candle flame. That is the middle zone, the yellow zone actually, also called as luminous zone, because it's the middle zone that gives out maximum amount of light. The light from the candle that you obtain, it is actually the light from the middle zone of the flame. So hence it is also called as luminous zone. Now it is moderately hot, like it is neither very hot, neither very cold, in between. Yellow in color. And what about the combustion? So combustion here also is not completely occurring. Why so? Because here also the wax vapors are not getting sufficient amount of air. Although it is getting more amount of oxygen in comparison to the innermost zone where there are unburnt wax vapors, but this one is getting moderately like more amount of oxygen from the air. So hence it is combustion is going here, but it's incomplete combustion, not 100%. Now we go to the outermost zone. That is also called as the non-luminous zone, right? Now, because there's a very thin zone over here, and it is not giving so much of light. Getting it, guys? You just try to visualize this thing. In a dark room, you have lit a candle, and in that dark room, you have turned on the burner. So which will be giving off more light? A burner whose flame color is blue because complete combustion is happening here, or a candle flame will be giving more light in that room, which will be illuminating the room.
The blue flame.
No. If you visualize it properly, it will be actually the candle that will be illuminating the room more properly. It will be giving off more light. Hmm? See, this is actually the non-luminous zone. Luminous, you understand, is something that gives off light. It is called as
Yes,
luminous.
sir.
So this zone is not giving off so much of light. It's actually the middle zone that gives off so much of light. So this outermost zone, it's non-luminous zone, but at the same time, it's the hottest zone, and here complete combustion is occurring. Why so? Because here the wax vapors are getting sufficient oxygen from the air, hence it burns properly. And the color here is blue. So that is the structure of the flame. Okay, now we are going to do some activities here. Okay. So the first activity here, in this, we are going to light a candle. Now we have taken a glass tube. Both of you turn your cameras on. You just have to listen. Priyanka, turn your camera on. So we have taken a candle. We have lit the candle. Okay, as you can see the flame. Now you will be taking a glass tube which is open from both the sides, and you are holding it with a pair of tongs. And where are you going to hold it? You are going to hold it in the dark zone of the candle flame, in the innermost zone of the candle flame. All right, now Bubakar and Priyanka. Okay,
Yes, sir.
so look over here. In the innermost zone or the dark zone of the candle flame, there's a difficulty in supply of air now. Air is not reaching there properly. Yes or no? Right?
Yes, sir.
So what will be happening here, as you have placed this glass tube into the innermost zone where unburned wax vapors are present. Remember what was written over here? It contains the unburnt wax vapors. So you have placed this candle, you have placed that glass tube in the innermost zone. So the unburnt wax vapors are going to go into this glass tube, as you can see here. This vapor that is unburnt vapors that have not burned properly. So it is going to pass from this glass tube and will go to the other side of the glass tube, right? So to the other side of the glass tube, you are bringing a lighted matchstick. So you have to brought a burning matchstick near another end of the glass tube. Okay. So as soon as you bring it, you will see that there will be a flame over here. A flame will be observed on the other end of the glass tube. So how did you obtain a flame here? Why? Because the unburned wax vapors, as it passed through the tube to the other end, it catched fire. It caught fire. So this activity was actually to show that the innermost zone of a candle flame consists of unburnt wax vapor. What was it? To show that the innermost zone contains unburnt wax vapor. That's why when the unburnt wax vapors from this glass tube travel to the other end, it immediately caught fire, and a flame was observed when a lighted matchstick was brought near to it. Abu Bakr, you read the given paragraph quickly.
Take a wax candle, fix it on a table and light it with a matchstick. Hold a thin glass tube with a pair of thongs and introduce one end of the glass tube in the innermost zone, dark zone or the black zone of the candle flame. See, now bring a lighted matchstick near the other end of the glass tube. We will see a flame at the end of the glass tube.
Okay. So why we are seeing a flame at the other end of the glass tube? Because there are unburnt wax vapors in the innermost zone of the flame. and it has caught fire. That's why flame is visible here now, right, Priyanka? So
Yes,
this
sir.
activity was to show that the innermost zone of a candle flame consists of unburnt wax vapors. So the questions might be asked in the exam to describe an activity to show that the innermost zone of a candle flame consists of unburnt wax vapor. So this is the activity that you guys will be required to explain. Okay, any confusions, any questions so far?
No, sir.
Okay. So tell me, what are the three different zones of the candle flame? What are
Outermost,
good. Next.
inner,
And middle
and
zone.
yes, sir.
Okay, which is the hottest zone?
Outer zone,
Huh. Which is the coldest zone?
inner
Hmm.
zone,
And which is the luminous zone?
middle zone,
Where? Very good, Prinka. Very good. Where are where complete combustion takes place?
outer,
Hmm.
um,
Yeah,
outer
that's
zone,
correct. Correct. And where incomplete combustion takes place?
inner zone,
Innermost zone. Very good, Prinka. Okay, which is called as the non-luminous zone?
outermost.
That is correct.
Yeah, outermost.
Yeah, that is correct. The blue zone, basically, right? Okay, very
Yes.
good, Prinka. Good. So in the upcoming classes, we'll be learning about some other activities, right? We will show that the luminous zone of candle flame contains unburned particles of carbon. You might have done this as a kid, like you would be holding this glass plate over this, and you will be observing this black patch over it. Right now, we'll be learning about that. Also, you would have seen this thing that the goldsmiths, if they have to heat a piece of gold, so they'd be holding it in the outermost zone of the candle flame or some other thing. Okay, so why they would be doing so, we'll be learning about all that in the upcoming classes. Okay, today I'm going to share this PPT with you guys. You guys are going to give a thorough reading of whatever things we have learned so far. All right. If there's any question, please tell me. Yes, are there any questions? Okay, okay. All right then. That's it for today's class. Okay, I will be continuing from
Thank you,
here in
sir.
the
Bye.
next class. Yes, you guys are welcome. Bye, everyone.
Thank you, sir.
Yes, bye. So, hey, Nafis, how are you?
Right, sir.
Nafis, I was going through your answer paper. Okay. And in this, I have observed one thing. See, in a mathematics exam, in a mathematics test, the most important thing is that you have to show the steps. First thing, what you have to do?
Usually I do the steps behind.
No. You have to show the steps in your answer. How do I get to know that how you got to got to this answer? In mathematics, you have to show the description. You have to show how you have uh, got the answer. So because of that, your marks was deducted. It is very important. I could have deducted more marks, but I have deducted only 2 marks because of this. Okay, you missed a very important thing. Second here, your answer needs to be neat and clean. But it's quite untidy. Then you had to follow the instructions. If you were to open the PDF and in the first 4-5 lines, it is written that like the test paper consists of total of 20 marks. You have to attempt any 6 out of the 10 MCQ, 2 out of the 5 2-mark questions, right? So that instruction has to be followed. So since you have done all the questions, thereby I did not deduct the marks for the questions which you got wrong. Okay. So, but anyways, let us discuss these questions where your marks were deducted. Okay, let me open the question paper on my phone. Okay, so this question here is question number. Which question is question number 5 actually, right? So question number 5, which of the following is the largest? So out of 1/3, 3/4, 2/5, and 1/2, right? So you have written 1/2 is also there. Hold on. See, so out of all these options, we see that 3/4, like there are 2 ways to solve this question, right? Now, one of the way to solve this question would be to basically convert this into decimal, and then you'll be getting the answer. Right now, you can convert them into decimal, and then you can get the answer. So after conversion in the decimals, you will find that the value of 3/4 is around 0.75. Well, 1/2 is 0.5. 2/5 is 0.4. 1/3 is around 0.3. So 0.3, 0.4, 0.75, and 0.5. So out of that, 0.7 is the biggest. So 3/4 was the right answer. So your marks was deducted. Other method to solve this question would have been to find the LCM, convert all of them into equivalent fraction, and then like convert them into like fractions particularly, and then compare them. Then look at question number 9. You there in the class, right?
Yes, sir.
So now in the question number 9. So question number 9 was you had to simplify 12/16. 12/16, right? So 12/16. So that would be 6 2s are 12, 2 8s are 16. Further, 3 2s are 6, 2 4s are 8. That would have been 3/4. You have written 6/8. 6/8 can also be simplified further, no? Because when you have to simplify,
Sir, are you discussing the paper or and after that we will do the lesson?
After that, we'll be doing the lesson. No, see, basically right now I am pointing the questions which you have done wrong. Like question number 9, you have to simplify the fraction 16 upon what was it again? You had to simplify the fraction 12/16. Let me actually get a bigger view. Hold on. Look, 12/16 we are going to simplify, right? So in order to simplify, what do? We first find the HCF now. So 12 divided by 4 and 16 also divided by 4. That's going to give you 4 3s are 12 and 4 4s are 16. So 3/4 would have been the right answer. So here your marks were deducted. Okay, na? And then the numbering of question number 18 and 19, that was not proper.
Oh yeah, I accidentally wrote greater than in 18.
Okay, no, anyways.
It should be less than.
Yeah. Getting it?
2 by 7 is less than 3
Mhm.
by 7.
Then question number 23 was you had to add 4 upon 9 plus 5 upon 12. Right.
Yes.
So there you got 16 upon 36. 16 upon 36. Okay, let's see. So first you will find the LCM of 9 and 12. So what's the LCM of 9 and 12? That should be 36. Right, and that should be 36. You'll be converting 4 upon 9. You'll be multiplying it by 4. So that's going to be 16 upon 36. And that's 5 upon 12 multiplied both by 3. And that's 15 upon 36. So now you have 16 upon 36 plus 15 upon 36